This is an introduction to radioactive decay. So what is radioactive decay? This is when the nucleus changes energy states in a way that the total energy of the nucleus is decreased. And this energy lost by the nucleus, because of a rearrangement, can be carried off by three different types of particles: alpha, beta, and gamma particles. So when electrons in an atom exchange their energy state by moving closer to the nucleus, the atom emits photons. So this is basically a Bohr diagram of an atom. And so you need to remember what the different energy levels mean. So are the lower energy levels closer to the nucleus or farther away from the nucleus? The lower energy levels are closer to the nucleus because remember that the further away from the nucleus, the higher the energy level. So that means the energy levels closest to the nucleus are the lowest, and the energy levels the farthest away from the nucleus are the highest. So if you have an electron here on this energy level and it wants to go down to a lower energy level, it's going to give off energy because here it had more energy than it needs, so it needs to get rid of that. And in this case, that energy would be emitted by a photon, which is basically a little packet of light energy, and it's proportional to the frequency of an electromagnetic wave of visible light. So basically, what that's saying is that it's like a little flash. So light energy would look like a little flash of light. So when an electron goes from a higher energy level to a lower energy level, that energy is given off in the form of a little flash of light. That is what a photon means. And this energy lost by atoms is millions of times less than the energy lost by the nucleus when protons and neutrons rearrange themselves. So this is like a lot less energy being emitted here than when you have stuff happening in the nucleus. That's why nuclear reactions have a lot of energy potential. And the reason that the electrons changing energy levels is not as much energy is because the electric force holding the electrons in place is a lot weaker than the force that's binding the nucleus together. So basically, the force holding the electrons in place is much smaller than the nuclear force. Remember, the nuclear force is what's holding the nucleus together. That's why we call it a nuclear force. So what are the types of radiation? There are three different types. We have gamma, beta, and alpha. So we're going to go through gamma first. So this is a very high energy electromagnetic radiation. Gamma decays release photons but don't change the number of protons and neutrons in the nucleus. And they can travel many centimeters through matter but do relatively little damage. So these are kind of hard to protect against. The way to protect them from it is using lead sheets. That's what stops gamma rays, because gamma rays have so much energy. So gamma rays are not changing the number of protons, so that means that an atom that gives off gamma radiation is not going to change its type, because the only thing that changes the type of an atom is changing the number of protons, and here the number of protons are not changing. Beta radiation is when a proton changes into a neutron and it's going to emit a positively charged electron. And so we call that positively charged electron a positron. So proton changes into neutron and gives off a positron, which is essentially a positively charged electron. Because when you think about it, a proton is positive and it's changing into something that is neutral, so it has to give off that positive energy, and it's like a little small packet of energy, so we call it a positron. And basically, the other way, when a neutron changes into a proton, it's going to emit an ordinary negatively charged electron. So when neutron changes into proton, it emits an electron. When a proton changes into a neutron, it emits a positron, essentially a positively charged electron. How can protons turn into neutrons? Well, your nuclear force is 100,000 times weaker than the strong force on the nuclear distance scale. So even though the nuclear force is still much more powerful than the electric, why don't positrons and electrons carry energy equal to the differences? Well, that's because of something called neutrinos. So basically what happens is when your proton changes into a neutron and your positron is emitted, the positron is not the same amount of energy as there was before. Now we remember that energy can't be created or destroyed, right? So scientists for a really long time were really confused. Where it was like a really tiny amount of energy difference, but they were going, wait, where is this energy going? It has to be going somewhere. So finally, when technology got a little better, in 1970, they actually observed a neutrino being emitted. And neutrinos always come from beta emissions. So it doesn't matter if your proton changes into a neutron or your neutron changes into a proton, you're always going to emit a neutrino. And basically the neutrino accounts for that little bit of energy difference that they thought was lost but is not actually lost. And it's really small and it doesn't do any harm. So the neutrino has no charge and really little mass, and so it can pass through pretty much anything without giving any damage. So neutrinos are not dangerous. Positrons and electrons both carry an electric charge, and they're going to damage matter as they pass through it. Their harmful effects are halfway between the damage caused by alphas and gammas. So gammas can cause damage because they can go through more matter, and betas can cause damage, but they can stop them with sheets of aluminum. So gamma, you need lead to stop it. Beta, you can use aluminum to stop it. And beta decay is going to change the number of protons in the nucleus because you either have a proton changing into a neutron or a neutron changing into a proton. So when you change the number of protons in the nucleus, does that change the element's identity? Yes, because the element's identity is based on the number of protons, aka the atomic number. So an electron is emitted when a neutron turns into a proton, and so you would then have more protons, so it becomes the next element up on the periodic table. Positron is emitted when a proton turns into a neutron, so in this case you'd have one less proton, so it would move down in atomic number. So beta decay changes the identity of the element because beta decay is messing with the number of protons inside the nucleus, and number of protons is how the element gets its identity. Alright, let's look at our third type of particle. The alpha particle is basically the nucleus of a helium atom. So this one is your biggest. So basically gamma is your smallest and alpha is your biggest. And because we have those size differences, gamma can pass through the most things because it's the smallest. And alpha can pass through the least things because it's the biggest. So essentially an alpha particle is basically the nucleus of a helium atom. How many protons are there in a helium atom? Helium is atomic number 2. That would be 2 protons and 2 neutrons. And in very big atoms, they have heavy nuclei, so they have the higher atomic number. The nuclear force is strong enough to hold in those alpha particles, and rarely, though, alpha particles can escape. And they're pretty much repelled by the nucleus because the nucleus itself has an overall positive charge. Why is the nucleus overall positively charged? Well, because the nucleus has protons and neutrons, so it has positive and neutral charges, so it's going to have a positive charge. So it's going to push those alpha particles, which are also positively charged. Why are the alpha particles positively charged? Well, an alpha particle has 2 protons and 2 neutrons, so you have 2 positive charges and 2 neutral charges, so your overall charge is going to be positive. So you have a positive nucleus of the atom that the alpha particle came from, and then you have the positive alpha particle, and so they're going to push away from each other, so the nucleus is going to push that alpha particle out and away from the atom. And they move really slow because they're heavy. They're the heaviest, relatively speaking, right? Compared to the other 2 types of radiation, they're the heaviest. But they can only travel short distances inside matter before reacting with something and doing a lot of damage. So alpha particles do the most damage. And basically alpha decay reduces the charge of the nucleus by 2 units, and your remaining nucleus is going to become a different element because it's losing 2 protons. and also 2 neutrons, but remember that protons are the ones that make it a different element. And the remaining nucleus is going to become a different element, and it's going to have a lower mass than the original element. So they're easy to block with paper. So alpha particles are the easiest to block, but they do the most damage. And basically, people get sick from alpha radiation and have the effects of it when they swallow any alpha particles. So pretty much alpha radiation is poisonous to people when it's ingested. And the danger with things like plutonium is that it can have a fine dust, and then you can inhale that. So then that would be ingestion. So like basically, if you breathe in alpha particles, then you're going to get alpha radiation, and that one's super damaging. So here are our 3 different types of radiation, kind of in a summary here. This isn't necessarily not necessarily one atom is going to go through all of this. This is just an example of the 3 types. So you can see them all and compare them. So alpha radiation is your biggest one, and that one is the easiest to protect from, but you don't want to eat it. Beta radiation is the middle guy, and this one only needs aluminum foil to protect against. Gamma radiation is the smallest and also the hardest to protect from, and you need lead. And here's another comparison of just looking at which particles can go through what. So you see gamma is the smallest particle, so it can pass through the most things. Beta is kind of the medium guy, so it can get you, but it's a little easier to protect from. And then alpha is the easiest to protect from because unless you eat it, you're okay.